The Science of Magic Beanstalks. You know the story, Jack and the Beanstalk. A boy trades a cow for some beans. His mom throws the beans out the window in anger, and by the next morning, there's a beanstalk taller than a skyscraper, climbing straight up into the clouds. Here's the question I want you to sit with. What if that actually happened in your backyard tomorrow morning? Could any plant on Earth really do that? Not in a fairy tale. For real. Short answer, no. But the reasons why are honestly way cooler than the magic. So let's climb this thing properly. Quick recap in case it's been a while. Jack trades the family cow for a handful of magic beans. His mom's furious and tosses them out the window. Overnight, a massive beanstalk grows up into the sky. Jack climbs it, finds a giant's castle in the clouds, steals some treasure, a golden harp, a hen that lays golden eggs, and, spoiler, has to chop the beanstalk down to escape the giant chasing him. Great story. Terrible botany. Let's fix that. Why can't a real plant grow that fast? Here's the thing about growth, plant or otherwise. It's not free. It costs material and it costs energy, and both of those take time to gather. Think about it like building with Lego bricks. You can't snap together a 5-foot tower if you only have 10 bricks in front of you. You need someone constantly bringing you more bricks. For a plant, the bricks are sugar molecules, and the plant has to make those sugars itself, one photosynthesis session at a time, using sunlight, water, and carbon dioxide from the air. A beanstalk growing to the size in the story overnight would need to build tons of new material. New cells, new fibers, new plumbing to move water in a matter of hours. No plant on Earth can photosynthesize fast enough to pay that bill. It's like trying to build a skyscraper in one night, using only the bricks your one worker can carry in by hand. The energy math just doesn't work. Okay, but some plants are shockingly fast. Let's meet bamboo. Now here's where it gets genuinely wild. Because there's a real plant that grows fast enough to make you do a double take. Bamboo. Certain species of bamboo can grow up to 91 centimeters, about 3 feet, in a single day. Some have been clocked growing almost an inch every hour. Sit and watch it long enough, and you could probably see it move. First surprising fact, bamboo isn't a tree. It's a grass. The same family as the grass in your lawn, just an absolute overachiever. So how does it pull this off? Here's the trick. Bamboo doesn't build itself from scratch every day. A young bamboo shoot already has all of its future segments pre-packaged inside it. Kind of like a folded-up telescope or a stack of paper cups. Each segment just needs to unfold and fill up with water, stretching to full length using water pressure. Scientists call this turgor pressure, rather than growing brand new tissue from nothing. It's less building a new floor of the skyscraper, and more popping open a pre-built floor that was already there, flat-packed. That's the loophole. Bamboo cheats the slow building problem by front-loading the construction and back-loading the unfolding. So why doesn't even bamboo grow all the way to the clouds? If bamboo can shoot up that fast, why does it stop at, say, 30 meters, instead of just continuing forever, Jack's beanstalk style? Two big reasons, and they both come down to physics, not magic. Reason 1. Water has to travel all the way up. Plants pull water up from their roots through tiny tubes called xylem, using a pull created by water evaporating out of the leaves at the top, almost like sipping a really long drink through a straw. But there's a limit to how far you can pull water this way before the straw runs into problems. Tiny air bubbles can form and break the water column, like a kink in a hose. Reason 2. The taller you get, the harder it is to stay standing. A plant's stem or trunk has to support its own weight without buckling, the same way a very tall tower of blocks gets wobblier the taller it gets. Trees solve this with a stiff material called lignin, basically nature's rebar. But even lignin has limits. Past a certain height, a plant would need to spend so much extra energy just building thicker support structure. So there's a real physics-based ceiling on plant height. It's not that nothing's stopping them. Gravity and fluid dynamics are stopping them. So what's the actual record? The tallest known living tree on Earth is a coast redwood in California, nicknamed Hyperion, standing around 116 meters tall. That's taller than a 35-story building. Coast redwoods and giant sequoias dominate the tallest trees list, partly because California's coastal fog gives them extra moisture that helps solve that water transport problem we just talked about. That's genuinely enormous. But even Hyperion, this record-holding giant, is nowhere near into the clouds where a giant's castle sits. It took that redwood centuries to get there, not one night. What does growth even require, really? Let's zoom out and ask the bigger question the whole story is dancing around. What does a plant actually need to grow at all? There's also a fifth ingredient worth knowing about, because it's the closest thing plants have to magic beans: plant hormones, especially one called gibberellin. Gibberellins are natural growth signals that tell a plant cells, stretch now. So here's where that leaves our fairy tale. A story where a plant grows to the sky overnight isn't just exaggerated for fun. It's breaking almost every rule we've just covered. But that doesn't make the story boring to look at with science eyes. It makes it a great checklist. Next time you hear about a plant doing something jaw-dropping, you now have real questions to ask. Where's the energy coming from? How's the water getting up there? Real growth is slower, weirder, and honestly more impressive than any beanstalk, because it's been quietly solving these engineering problems for hundreds of millions of years. No magic beans required. Nature is more impressive than magic.